Hello and welcome back to the Big Bold Health Podcast, making health personal in a world of disease. If you have taken your first steps into the world of personalized health, you probably have gone beyond fat, carbohydrates, and protein. Whether that's brought you into the light or whether that's taken you further into the dark is up to you. But we're going to go really dark here today. Jeff, how dark are we going to go?
Well, James, that's a very great way to introduce a topic that I think is now starting to come into the light, and that's what I call the dark matter of nutrition. Now, that sounds like maybe something one wants to avoid, but actually I don't think so, because there's a lot of good information that is useful for personalizing health involved with dark matter of nutrition. So let me define what it is based on my view. So there has been tremendous amount of work, research, and studies and discussion, and many, many thousands of books published on protein, carbohydrate, fat, and even vitamins and minerals and essential fatty acids like the omega-3s, omega-6s, omega-9s. I mean, we have a lot of information out there. And so it begs the question, is that the whole of nutrition? If we handle those variables and we personalize them correctly, will it guarantee that we're going to have a really great outcome? And the answer to that question is no, because we're missing another very important part of the emerging nutrition story, which is what I've called dark matter, meaning it's less understood and less in the light. And that has to do with what we call phytonutrients or phytochemicals, and it has to do with other constituents of food, which I'm going to be talking about in a moment here, maybe sounds a little more esoteric, called small inhibitory RNAs. We're going to come back to that in a second. Let's focus, however, first on phytochemicals. As we know, phyto is plant, chemicals, so chemicals from plants. And plants make these various things like curcumin, from turmeric, or make didzine and other isoflavones from soy, or make epigallocatechin gallate from green tea. These are known names that a chemist gives to families of these phytochemicals. And it begs the question, why would a plant go to the trouble of making all these esoteric chemicals, of which, by the way, there are probably more than 5,000, close to 10,000 of these different chemicals that have been identified that plants make. And I want to emphasize, these are not pollutants. These are things that the plant makes as part of its machinery that guarantees its function. So the reason for these is that a plant has a pretty difficult life. As you probably know, plants grow on the ground or on some stationary surface. They generally can't run away from invaders. They can't fight their way easily. Maybe the Venus flytrap would be an example, but most plants can't fight their way away from their invaders. So they have to develop very adept chemical warfare in order to do this. And these chemicals they make are called phytochemicals that are locked into their genes. So every plant makes a different family. They could be carotenoids, they could be flavonoids, they could be polyphenols, they could be isoflavones. I mean, there's all different families of these phytochemicals. And as I said, if you group them together, it's thousands and thousands of them, each of which has different function in the plant. Some are plant hormones like phytoalexins. Some are plant sunburn creams that prevent a plant from being sunburned. I mean, think of what a tough job it is being a corn plant in Iowa in the summer, where you can't run and hide in the shade. You just get sunburned, and so you have to develop your own sunscreen, which are these flavonoids and carotenoids that soak up the sun's energy before they burn the plant to death. And what happens in the fall? When a plant stops photosynthesizing, what does it lose? Its green chlorophyll, and then what shines through in the leaves of trees? The color brown and the color red. What are those? Those have been there all summer long. We just didn't see them because they were masked by the green of chlorophyll, and they're the solar sun cream that are called the carotenoids. So plants are making xanthophylls, they're making beta-carotene, they're making zeaxanthin, and all sorts of these substances that are there to help protect the plant against sun injury. So when you put all these chemicals together, you would say, what do they represent? They represent the plant's anti-stress compounds. Think about that for a moment. They're actually helping the plant defend itself against stress so the plant can stay healthy. Remember, we talked earlier in one of our episodes about the World Health Organization's definition of health was full function of cognitive, emotional, physical, and physiological function. and the ability to adapt to change. Well, that's what these things are there in the plant to do, to allow them to survive through the course of their period of life. So if these are anti-stress compounds, then what happens if we eat them? This is a very interesting story, because those compounds, when eaten by humans, are anti-stress compounds. Ooh, that's an interesting concept.
Yeah, so we should learn from them and then consume them anyway.
That's right. And now let's ask another question. So where would you find, let's use a broccoli as an example, a broccoli plant. Where would you find the highest level of glucosinolates in broccoli? That's the phytochemicals that the cruciferous vegetables make. They're called glucosinolates. Would it be in broccoli that was grown in very controlled conditions, hydroponically grown with the standard fertilizers and solar radiation that was controlled and water moisture that was controlled? Or would it be in a environment with high stress that we call organic?
Yeah, I would say high stress.
That's exactly right.
Yeah.
Sometimes you have 2 to 3 times the amount of phytochemicals in some of these plants that are grown under some stress versus, and organic is stress, because you get rid of all the rust and the organisms and the parasites and the invaders by using biocides and insecticides and weeds with herbicides, and now you got that plant living in hardly any stress. So the construct is that if you are then consuming diets that are rich in these phytochemicals and from a variety of different plants, that you're doing coevolution. You're doing coevolution because we've evolved with those plants. We've depended upon them. We ate a variety of diets. We didn't grow up with grocery stores and refrigerators. We ate these plants in the wild, and they were not horticulturally grown in high biocide environments with fertilizer. They were grown in the wild, so they were stressed. So our bodies learned over, when I say learned, what I really mean is genetic selection over millions of years, to have this relationship with our food. So I'm calling this dark matter because these have not come totally into the light of day as being as important as our vitamins and minerals in some context for regulating how genes are expressed. The way these compounds actually work is they modulate the executive centers of our genome that regulates how our genes are expressed into their function. That's a highfalutin, a bunch of language. What does it really mean? It means as we eat these anti-stress compounds in foods, these phytochemicals, they participate in very cellular specific anti-stress functions in the body. And different plants have different effects on different organs to produce anti-stress activities. So people talk about a diet of variety, so that we get a variety of these plant foods. Or people also talk about a variety of colors in our diet. Now, why colors? Why eating a rainbow diet? Because each of these phytochemicals, when you extract them from the plant, it turns out that they often have their own individual colors. They may be like blue from blueberries that have certain kinds of characteristics that are different than red from tomatoes, that are different from green from spinach, that are different from brown from wheat, that we have differing kinds of influences that somehow is related to the color, because the color is imparted by the personality of these different phytochemicals. So eating the rainbow is one way of introducing a phytochemically rich diet. I'm not talking about synthetically colored foods, obviously. I'm talking about the natural stuff in the foods. And you find these mostly, don't you, in plant foods. Now you might say, well, meat is red. There is red meat. That's hemoglobin. That's rich in iron. Yes, but I'm talking well beyond the color red of hemoglobin. I'm talking about all these thousands of different phytochemicals that plants uniquely make. So I always find it kind of enigmatic when I hear people talking about, we ought to be eating a paleo diet, in which to them a paleo diet means it's a big animal product diet. And, we ought to not be eating a lot of plant foods because humans didn't have a lot of plants. We didn't cultivate plants. Well, it turns out that anthropologically that's not true. We ate a lot of plants. We used the grasping thumb and forefinger that separated us from other animals to pick stuff off plants and to eat them. And it has always historically been a major part of our diet, much more so than animals. Remember that we didn't have high-powered rifles and adept ways of getting animals trapped in husbandry like we do today. Yeah. So we depended upon plants for a great percentage of our diet. So I think that this construct of the dark matter called phytochemicals is a very important part of personalizing our diet, making sure that we have adequate levels.
Yeah, we focus a lot on the genes of the human, and we talked about nutrigenomics before, but what we're really talking about is sort of like the genes and the dark matter of the things that we're interacting with, right? The plants that play a huge role, and the connection in the microbiome. Where's that all going in the world of personalized health?
Oh man, am I glad you brought that up. We're having fun. The microbiome. So we've got this community of organisms that live in our colon. I know this is not a very socially acceptable topic in my household. Unfortunately, as a consequence of my propensity to talk about this, my kids grew up talking about bathroom stuff at the dinner table, which was really socially unacceptable. But they kind of get used to it over the years because it was a topic of conversation. But the fact is, our colon has about 2 to 3 pounds, depending on who we are, of living organisms. 2 to 3 pounds of living organisms. It's called our microbiome. Now think of that for a moment. The number of genes that are present in these microbial organisms that are very, very small relative to the size of cells of our body. These are called prokaryotic cells. They're very small, the bacterial cells, versus our eukaryotic cells of our human. So we have many more prokaryotic cells in our body in terms of number. Therefore, we have many more types of DNA in our body coming from our microbiome than we have DNA or cells in number of our body total, our eukaryotic cells. Now, obviously, the size of our cells are big, so most of our body in mass is our eukaryotic cells, but most of our body in numbers are microbial cells. And they have their own personalities. And there are literally thousands of different microbes that live in community with us. And those three types of microbes fall into three categories. They can be either symbionts, meaning they help us out. They make vitamins, they make amino acids, they make immune stimulating factors. So that's called symbionts. They make the second class, it would be called the commensals. They reside in our gut, but they don't really do us good, but they don't do us harm. They just take up space. It's like a camp out, right?
Yeah.
We have different people with different camping regions. And then lastly, we have what are called the parasitic family. Now, in 1 gram of stool, which is 1/30th of an ounce of stool, there are more bacteria than there are stars in the universe.
Wow.
Let me let that sit in for a second. 1 gram of stool, more than you have stars in the universe. Something like 10 to the 14th bacteria per gram of stool, of which in a healthy person, 10 to the 10th of them are friendly or commensals. Only 10 to the 3rd to 10 to the 4th are parasitic. And so the parasitic are kind of kept in control by all the other campground visitors. But what happens if the parasitic family grows in number at the expense of lowering the number of symbiotic or commensals? Now we get into what's called dysbiosis. Now, why is that important relative to the dark matter of nutrition? Because these bacteria are producing their own secondary byproducts. Remember, they're living organisms. They're eating food, which is the stuff that they're fed from us, and then they are giving off waste products. Yeah. And they're also dying, and their carcasses are, which are called the exoskeletons of their cell walls, are also down there as well in our gut. Our gut is where 50% of our body's immune system resides. Yikes. You mean 50% of our body's immune system is coming in contact with stuff that's going on in our gut, some of which is hostile? Yes. Mm. And how do these bacteria then relate to the dark matter of our nutrition, like these phytochemicals? They eat phytochemicals too and convert them into secondary byproducts, some of which are helpful, like equal is a good example from a soy conversion into a favorable phytochemical in our body by the bacteria. Some bacteria, not all bacteria. This is species dependent, so it can vary from person to person. Some people are equal producers, others are not, based upon their bacteria in their gut. And those bacteria and their secondary products can either be helpful for us or they can be harmful for us. And when I say harmful, they can harm our immune system by producing a response of a foreign invader that causes inflammation. And they can influence toxicity of the brain and create things that are as serious in older age individuals as hallucinations and psychosis in the cases of really serious endotoxemia and bowel overgrowth. So what I'm saying is that we have this complex environment of what we eat, how it's processed by our microbiome, and how that regulates how our genes are expressed. So when you're talking about nutrition to be personalized, you want to know something about your digestive ability. You want to know something about the nature of the richness of the phytochemicals you're eating, and you want to know how they're influencing your personal health outcomes. This is the new nutrition of personalized healthcare.
You know, when I first heard about this in 2012, I was certainly way ahead of the curve in terms of society understanding, right? The old understanding of microbes being mainly parasitic and bad for you, and now understanding the sort of the key role that they play. I just sort of thought that as this played out, the world of medicine would be turned on its head, health would be turned on its head, everyone would really start to understand this. But it's sort of like, in a certain way, it's happening, but we're still kind of living in the dark ages with this conversation. What's it going to take to bring this information into something that's real for people, for the average person, to access the potential of this information to transform public health through personalized health?
Thank you. I think that's where the tar meets the road, isn't it? That's the point of action. So I think I can answer that question depending upon my outlook. Is my cup half full or cup half empty? And I can either say, gee whiz, we have a long road to go. We're just in the early stages of adoption and making this accessible. Or I can say, look at what's happened over the past 10 years. Look at the revolution in fermented foods. Look at probiotics, which didn't even exist as a category in consumer nutrition 10 years ago at any significance, and now the frequency of how people are bringing this up. Look at how we are seeing increased consumption of fresh fruits and vegetables starting to become a part of the new nutrition of cuisine and of top chefs and people who are known to be connoisseurs, gourmands, and gourmets of nutrition. So I think that we're witnessing, to me, the front edge of what is a hockey stick in change. And as we know, adoption of these principles often occurs first at the early adopters, who then are seen as leaders, and then they get the information out, and then that starts to be tried by people until eventually it starts to gain to some critical mass. Some people call it the 100th monkey syndrome, and then it shifts over. When I look back to my start in this field, I go back 39 years. I just had this experience occur within the last few weeks, that I met with a good friend of mine, Doug Green, who was responsible for really starting what's called the Natural Foods Expo 39 years ago. I was involved with the development of the educational programs for his meetings for the first decade and a half. And Doug and I were reflecting on 39 years of that meeting. When the first year that meeting was held in the Anaheim Convention Center in California, I think there were 2,000 people that attended and about 300 exhibitors that had products in that field. I just went to the meeting in 2019. There were 108,000 attendees and over 2,000 booths and exhibitors that are producing products.
It's like the Super Bowl.
Yeah, it exactly was. And the change of the organic food movement, the change in sustainable agriculture, the change in food and nutrition that I see. Now, admittedly, these are the health-conscious consumers, but we're starting to see organic products in all markets now, in all sectors. So my feeling is that these things happen not on a regular kind of well-planned. It's a little bit of a disruptive innovation that occurs, but if it's truth, it filters through eventually, and it creates its own new markets. And I think that is what's happening. And that's why we are doing Big Bold Health. Yeah. We're sick and tired of being handmaidens to the disease care model. We are saying health is really here for our taking if we just redefine it and personalize it in such a way that we own our health and we're not co-opted by the disease care system.
Absolutely. I mean, I moved to America in 2005, and at that moment I lived in Georgia. And rural Georgia too, not cosmopolitan Atlanta. And at that moment, there was no organic food section in the supermarket. And 13 years later, it's 2/3 organic. And even people on the outskirts of, in rural Georgia, it's coming to fruition. And I see that people that are out there are making it easier and easier for people to participate. Nutrition is a topic that has almost no end as far as like its complexity. But I think what you're kind of saying is, despite the complexity of the mechanisms, the principles are quite simple.
Well, I think you've just said it. The word I would use, it's a word that's been popularized recently, simplexity. Out of complexity comes simple applications that can be done by the person without being an expert in the process. Simplexity. And that's what we're trying to deliver in Big Bold Health. We're trying to take complex topics that are on the frontier of personalized health and translate them down into the simple applications that a person can do that make meaningful differences in their own lives. That's the objective.
Simplexity here at the Big Bold Health Podcast. Thank you, Jeff, for being here again. This has been the Big Bold Health Podcast. We've been talking about the dark matter of nutrition, and we'll be back next week with a new episode. Thanks so much for listening. We'll see you next time.